Well, the derivative of the regular logarithmic function or natural logarithmic function is pretty simple. It's 1 divided by the argument. So in this case, 1 divided by x. And if this is anything more complicated than just an x, you need to use the chain rule. So we would then have to say multiplied with the derivative of whatever the argument is. So in here, we're going to have 1 divided by that thing. So the derivative with respect to x is going to be 1 divided by 1 over x. And now, according to the chain rule, we need to take the derivative of the inside function, so the derivative of 1 over x. That's another one that I like to just remember, and I remember that it's negative 1 over x squared. So you could say, well, if you had y equal 1 over x, then rewrite that as x to the negative 1, and then the derivative of x to the negative 1 is negative x to the negative 2, and then that means it's a negative 1 over x squared. Or you could just skip that step and go straight to that one. So with this one, you say, all right, take this thing and then multiply it with the derivative of 1 over x, which is negative 1 over x squared. And then we'll simplify it in the next step. And then for this one, well, this one is basically like y equals 1 over x, except instead of an x, it's a natural log of x. So we could go through these same steps, and instead of this being an x, have a natural log of x. So we have negative 1 over the natural log of x squared. But then I have to consider that this was actually the inside function. So I can say 1 over the natural log of x can be rewritten as the natural log of x raised to the minus 1, and then take the derivative of that. So it's going to be negative 1, and then natural log of x, subtract 1, it's to the negative 2. Which is what I have so far. But then the chain rule applies, and you have to take the derivative of the inside, so you have to take the derivative of natural log of x, which is an additional factor of 1 over x. So then this needs to be multiplied with 1 over x. And then finally, what about natural log of natural log? Okay. Well, this is the outer function, that natural log. So the derivative of it is 1 over whatever's inside the parentheses. So it's going to be plus 1 over whatever's inside the parentheses. And then again, the chain rule applies. So this was what's inside the parentheses. You then have to take the derivative of that, which is a 1 over x. Okay, now I need to clean these up. So with this one, I could invert and multiply, or in other words, multiply by x and multiply by an x. So the first fraction is going to be pretty simple. It's just going to be minus 1 over x, because these guys will cancel. One of these will cancel, so it's no longer x squared. It's just negative 1 over x. Over here, I can multiply by x so that these can cancel, but I have to do the same thing on the denominator. So it's going to leave minus a 1 on top, and x, parentheses, natural log of x is squared. And then almost the same thing on this last one. Multiply by x and multiply by x. So it's going to be a positive 1 over x and natural log of x. And then just for some additional fun, what we could do is add these three fractions. The common denominator is right there. So So this one is lacking a natural log of x, so multiply by another natural log of x on the top and the bottom. This one is missing the natural log of x squared, so multiply by that on the top and bottom. So we would get common denominator is x and natural log of x squared. And then we've got negative, the natural log of x is squared. From this one we have plus the natural log of x. And from this one we have just a -1. Lovely.